Hello friends, I welcome you in lecture number 14 on relations. In this lecture we are going to discuss this question on the properties of relations, and this question was asked in GTU Winter 2020 exam. First we understand what is this question. It is given that capital N denote the set of natural numbers and relation R is defined in this set as two elements x and y are related to each other if and only if they satisfy this equation x plus 3y equal to 12. That is, two natural numbers x and y are related to each other if they satisfy this equation x plus 3y equal to 12. And we have to examine this relation for these three properties: reflexive, symmetric and transitive. So first we write down that relation R is defined as we have to consider those elements in this relation for which these components of order pair are natural numbers, that is xy belongs to n, and they satisfy this equation x plus 3y equal to 12. That means we have to find out the natural numbers which satisfy this equation. That means we have to find out the solution of this equation. So this again we can rewrite as xy belongs to n, and this I can rewrite as x equal to 12 minus 3y. This means x depends on y. For different values of y can be taken arbitrarily, and for different values of y we will obtain different values of x, and here we have to take care that we must have x and y as natural numbers. So natural numbers are starting from 1. If I take y equal to 1, I will have 12 minus 3 into 1, that is 12 minus 3, which is 9. If I take y equal to 1, I obtain x equal to 9. So one element is order pair 9, 1. This is for y equal to 1. Suppose I put y equal to 2 in this equation, then I will have x equal to 12 minus 3 into 2, that is 12 minus 6, which is 6. For y equal to 2, value of x is 2. So another order pair is 6, 2. Now suppose we consider y equal to 3. Then we have 12. Here we are putting y equal to 3. So we have 12 minus 3 into 3. That is 12 minus 9, which is 3. That means order pair for y equal to 3, x is 3. That is order pair 3, 3. Now suppose we consider y equal to 4 here, then x is 12 minus 3 into 4, that is 12 minus 12, which is 0. But 0 is not in the set of natural numbers. So for y equal to 4, x becomes 0. So we cannot consider this order pair 0, 4, because x is 0 now, and 0 is not in the set of natural numbers. Here we have to take care that in the order pair xy, x and y are natural numbers. Now if I take y equal to 5, then I will have negative integer. Y equal to 5 will give me 12 minus 15, that is minus 3, which is also not a natural number. So you can see we have only 3 ordered pairs which satisfy this equation. There are only 3 natural numbers, not natural numbers. There are only 3 ordered pairs of natural numbers in the given relation. So this relation is a finite set. It is given in terms of this condition x plus 3y equal to 12, but the number of solutions of this equation are finite. They are only 3. There are only 3 solutions for this equation, provided that x and y are natural numbers. If x and y are integers, then there are infinite number of solutions, but here due to this condition that x and y are natural numbers, we have only 3 elements in our relation. Now once we have finite relation, it is easy to check all the properties. First we check for reflexive property. So for reflexive property, we must have this type of elements, diagonal elements in our set for every x in the set of natural numbers. So that is not possible here. We have only one diagonal element 3, 3, but for every natural number this is not possible. So it is clear that R is not reflexive. We can write that for x equal to 1 belongs to n, 1, 1 is not in this relation. So this relation is not reflexive. So we can write justification that why it is not reflexive. For 1 belongs to n, 1, 1 is not in given relation, or we can say that 1 is not related to itself by this relation. Therefore this relation is not reflexive. And for symmetry, we have to check that whenever we have ordered pair xy in the given relation, we must have ordered pair yx in the given relation, or whenever x is related to y, we must have y related to x. So that is obvious here. We can see that for first order pair 9, 1 belongs to R, but 1, 9 is not in R. So therefore this is not reflexive. Okay, we can write in this way that for these two natural numbers, for 1, 9 belongs to n, we can say that 9, 1 belongs to R, but 1, 9 is not in R. This means R is not reflexive. We can write in this notation also. Instead of writing in this way, we can write that for 1, 9 belongs to n, 9 is related to 1, but 1 is not related to 9. So either we write in this way or in this way. These are the same things. These are two equivalent notations for element to be in a given relation. So this says that relation is not symmetric. Therefore R is not symmetric. Third one is transitive property. So we recall that for transitive property, we have to check that whenever xy belongs to R and yz belongs to R, we must have x, z belongs to R. If this is happening, then we must have this xz belongs to R. Whenever xy belongs to R and yz belongs to R, we must have xz belongs to R. So if this happens, this must happen. Now if this does not happen, that means relation is transitive. We cannot find out any two ordered pairs of this type, then relation is transitive. So what is the characteristic of this property? That second component of this ordered pair is the first component of this ordered pair. So if we can find out this type of ordered pairs in a relation, then we must check this one. But here you can see, if I start with first element 9, 1, then here second component is 1, and we can see in these two ordered pairs second component is not 1. Similarly, if we concentrate on this ordered pair, then second component is 2 here, and for these two ordered pairs first component is not 2. Similarly, if we check for this element, then here second component is 3, but 3 is not the first component of any other ordered pair. This means we are not having this type of elements, xy belongs to R and yz belongs to R. That means we can write that clearly our relation R is transitive. If it is not transitive, then we have to show the existence of these two ordered pairs. That is, we have to show that xy belongs to R and yz belongs to R, but xz is not in R. But here there is no ordered pairs of this type, therefore our relation is transitive. So this is very nice question. Here we have discussed that this relation is not reflexive, it is not symmetric, but it is transitive. And the interesting thing is this part, that relation is given using this condition, but the number of non-negative solutions or number of solutions for which xy belongs to n are finite. Therefore this given relation has only 3 elements, and we are able to check easily these 3 properties of this relation. So this is all about this session. I hope you like it. Thanks for watching.